All right, the front of this paper is not at all about z-scores. It is just review of 5-number summaries, finding the mean, finding the MAD, finding the standard deviation. But I do want you to pay attention to the directions. This whole side right here, you're going to calculate all of this stuff by hand. So you're going to order the data, find the 5-number summary, all of that by hand. This side, however, I want you to follow the directions down at the bottom of your paper about using your calculator to find statistical information. And the chart off to the right, I want you to write down all the numbers that you find. Once you follow those instructions, you're going to pull up a screen that has all of those things on it. Then, after you fill out that chart, you're going to come up here and fill this information out. The only thing that has to be done by hand is the MAD. Okay, and the box plot, of course, I'm expecting you to do the box plot by hand once you get the 5-number summary. But when you do this side, you're following the calculator instructions. This is blacked out because you don't have to order the data when you use your calculator. So stop the video right now, complete this whole front side. When you're done with that, then tune back in. And so here are the answers to the first side by hand. I'll do not very much explaining, but I just wanted to point out this is where I split the data right in half. So I found the lower quartile, the upper quartile, the min and the max. And so there's your 5-number summary. That says 91.5 right there. Box plot, pretty self-explanatory. I just wanted to remind you that your box plot goes above a number line. You just don't put your 5 numbers anywhere you want to on the number line. You have to actually make a number line. The mean is 89. I got 5.4 for my MAD. Here's my work. If you forget what to do, or if you didn't get the right answer, that says 54 divided by 10. And then the standard deviation is 6. Remember, if you got 36, you forgot to find the square root of both sides. So, or not of both sides, just find the square root. So then you can get it. But there's my work in case you need it. Again, when you do this side over here, if you haven't done this side yet, again, just a reminder, do the side with your calculators. And so on your calculator for this side over here, this is what you should have gotten. 5-number summary, box plot, the mean. The MAD had to be done by hand, so if you did not get 8.5, take a look at the numbers I put up here. I got 68 over 8 to give me 8.5, and then the standard deviation is 9.5. And all of that information should come right off of your calculator side, which has the calculator steps. And here are the answers to what you should have gotten. So just point out main things that are super important right here are your mean. This right here is your mean, sample mean. We'll talk about the word sample in just a minute, but that's the average of it. The other one that's super important is this standard deviation right here. For the standard deviation formula that you will use, this is your standard deviation. When you get into high school, you'll talk more about sample standard deviation and what that means, but for our class, you're just going to use that 9.75. The N tells you right there, it's the number of data values, so like you have 8. So this is a really helpful, like if for some reason you missed a number, like if that said 7 or something, you forgot to put a number in, so that's really helpful. And then scrolling down, you would get your 5-number summary, which is super helpful right here. So if you're going to remember these calculator steps, there's no need to actually know how to do the box plot in your calculator. You can get by with not remembering how to do that. But these are super helpful and important. So let's go ahead and backtrack to the other. So far, we have been talking about mean absolute deviation, variance, standard deviation, and all of those pieces of information are talking about the spread of the data as a whole. And so what we haven't talked about yet is individual pieces of data. So for example, on the first side of this paper, we talked about Spanish tests for certain kids, and we talked about English tests for certain kids. FYI, this information is in the first column of the first page, and this information is in the second column. For some reason, these two things are switched around. I'm sorry about that. It's a little confusing. But z-scores, we're going to talk about individual data points. And so there's a formula for a z-score, which you will be given a formula sheet, and you do not have to have this memorized. But the z-score here looks like this. It's x minus mu over standard deviation. That's basically what it means. So you take the data point, you subtract the mean of the information you're talking about, and you divide it by the standard deviation. And that gives you an individual z-score for an individual point. So let's just take this Spanish test information for just a minute. So these kids, Sarah, Jay, and Christina, they all took the Spanish test. So what we're going to do, flip back to the front, and you want to find Sarah, Jay, and Christina's score on the Spanish test. So I have that Sarah got a 92 on her Spanish test. Jay got a 92 on his Spanish test as well, and Christina got an 81. And then let's go over and look at the English test as well. So Sarah also took the English test. She got a 92 on the English test. Jay got an 83 on the English test. And then we've got Jimmy and Madison down here who did not take the Spanish test. So we've got 81 for Jimmy, and we've got Madison was 92. So if you don't know where I'm getting these numbers, I'm basically just getting them from the front of the sheet of the paper at the top. So now what I need to do to figure out the z-score is I have to subtract the mean from the Spanish test. Like if I'm looking at Sarah's score, what I need to do is I need to subdue her point minus the mean of the Spanish test. Then I'm going to divide it by the standard deviation, and that's going to give me her z-score. So let's go back to the front again, and let's just take a look and see, okay, for the Spanish test, it's a good idea to write this stuff down on this paper. For the Spanish test, we got that the mu, the mean, was a 79.5 for the Spanish test, and the standard deviation was 9.75. So that's the data that we're going to use for the Spanish test. Then for the English test, we got that the mean was 89, and the standard deviation was 6. So that's the information that we're going to use to help us get our z-scores. So Sarah's deviation from the mean, we're going to do 92 minus 79.5, and that gives me 12.5. Then I'm going to take that 12.5 and I'm going to divide that by 9.75 because that's the standard deviation. And let's just round to the tenths place, and that gives you 1.3. So of course Jay, same test, same score, his information is going to be the same. 12.5, 1.3. All right, so Christina, we're going to take her score, 81, we're going to subtract 79.5, and then we're going to divide it by 9.75. So 81 minus 79.5 gives me 1.5, and then I'm going to divide that by 9.75, and that gives me 0.15 something. Let's just round that to 0.2. So those are the z-scores. Let's go ahead and calculate the rest, then we'll talk about what in the world this means. So now the English test, so now we're using this data right here, the English test data. So we do 92 minus 89, that's 3. Divide that by the standard deviation of 6, so 3 divided by 6 is going to give us 0.5 exactly. Then I'm going to do 83 minus 89, and this time I get a negative number. Z-scores can be negative. So that's different than the stuff we've been learning before. So negative 6 divided by 6 is negative 1. So Jay's z-score on his English test was negative 1. All right, let's do Jimmy. So Jimmy was 81 minus 89. That gives me negative 8. Divide that by 6, and you're going to get negative 1.3 repeating. Let's just say that's negative 1.3. We're just going to round to the tenths place today. And then the next one, 92, we already did 92. So 3 standard deviations from the mean, divide by this standard deviation, and you get 0.5 again. Okay, so the sign of a z-score tells you if the data point, basically, is above or below the mean. A negative z-score is below the mean, and a positive z-score is above the mean. So what these z-scores are doing is they're telling us how many standard deviation a score is above or below the mean. So, for example, a z-score of 1.5 means that the data point is 1.5 standard deviations above the mean. So do you remember that bell curve and how we were saying you're 1 standard deviation above the mean or 2 standard deviations above the mean? These scores right here are telling us where everybody is in comparison to everybody else in the class on that particular test. So let's analyze some of these scores on the next page. All right, so number 12, use z-scores to compare Sarah's score on both tests. Well, Sarah got a 92% on both tests, right? But her z-scores are different. So let's just get a visual. Let's go ahead and draw the bell curve. And remember, the bell curve, what goes in the middle is the mean. Now let's think about this. If you scored the mean, you are 0 standard deviations from the mean, right? You scored the mean. So your z-score would end up being 0, right? If you get a 1, you're 1 standard deviation above the mean. If you get a 2, you're 2 standard deviations above the mean, and a 3. So then negative scores are below the mean. So this is what the bell curve typically looks like. And the z-scores tell you where to go. So Sarah's z-score on her, what are we talking about? The Spanish test. Her z-score on the Spanish test was a 1.3. So she falls right about there, right? She got a 1.3 on the Spanish test. And then we could say on the other test, the English test, she got a 0.5. So she falls right here. Now, even though she got the same exact score on both tests, we could say she did better on the Spanish test in comparison to the rest of the class. So that's what we're going to say. Sarah did better on the Spanish test compared to the rest of the class. Whoops, I forgot the word "to" there. The rest of the class. Right? Her z-score was better. So in comparison, she scored well above the mean, way more above the mean than she did on the English test. She did great on both tests, but Spanish test wins. All right, so now number 13, use z-scores to compare Jay's scores on both tests. Well, Jay on both tests got on the English test, he got a -1, and on the Spanish test, he got a 1.3. So this one's actually pretty easy. Jay did way better on his Spanish test, and that's true of his actual score anyway. So Jay, we would say, did better on the English test. Nope, I'm sorry, that's a lie. The Spanish test. Because he scored 1.3 standard deviations above the mean. That's another way of just saying it. Above the mean. Okay? So he scored like right about here, and then on the other test, he scored way down there. All right, number 14. Use z-scores to compare Jimmy's score on the English test with Christina's score on the Spanish test. So Jimmy's z-score on the English test, he was a -1.3. And Christina's score on the Spanish test, she was a 0.2. So we don't even actually care what percentage they got on these tests. We just want to know, how did they compare to the rest of the class? So we're basically going to say Christina did better because she scored 0.2 standard deviations above the mean, whereas Jimmy, he scored below the mean. Starting to make sense? So these numbers are just telling you where they end up going on that bell curve that we learned about the other day. All right, let's take a look at the next questions. Okay, number 15. Jimmy was absent on the day of the Spanish test. He took it after school one day, and Mrs. Mexico told him his z-score was 1.7. What was Jimmy's test grade to the nearest whole number? All right, that's kind of annoying that his teacher's like, here, have a z-score. Your z-score is 1.7. He would need the rest of the information, though. He would need to know the class average, and he would need to know the standard deviation. So let's take a good look at that formula again. So z-score equals the test grade minus the mean over the standard deviation. We have 3 out of 4 of those pieces of information. We have his z-score is 1.7. So I'm just going to plug this stuff into the formula. 1.7 equals, we don't know x. We don't know what he got. But didn't we get that the Spanish test had an average of 79.5, right? Over the standard deviation of 9.75. So let's go ahead and figure out his score. all we have to do now is solve this equation for x. So multiply both sides by 9.75. And when you do that, you should get 16.575 equals x minus 79.5, and then add 79.5 to both sides. And when you get that, you're going to get that x is equal to 96.075, which we're rounding to the nearest whole number. And so Jimmy, he got 96% on that test. Good job, Jimmy. Okay, number 16. Paula was absent on the day of her English test. After she took it, Mr. Nice Guy told her her z-score was negative 0.9. What was Paula's test grade to the nearest whole number? Poor Paula, she scored a below the mean, but that does not necessarily mean that she did that bad on the test. So let's figure out her score. Same idea. We're going to use this formula. We know her z-score, negative 0.9, right? Is equal to, we don't know her score, but now we're talking about the English test. So the English test had a different mean. Remember, English test had a mean of 89 over the standard deviation was 6. So we're going to go ahead and solve that. So multiply both sides by 6. And you get negative 5.4 is equal to x minus 89. They're going to add 89 to the 5.4. So you know what? She didn't really do that bad. So she got x. We're going to get x here is equal to 83.6. We're going to round that 83.6 to an 84%. So she got an 84%. Okay, so now when is this stuff super helpful? This stuff is super helpful if you're comparing two different tests that have completely different scales, right? So for example, Amy scored a 31 on her mathematics portion of her 2009 ACT. And Stephanie scored a 720 on the mathematics portion of her 2009 SAT. And we have SOL scores, which we could get anywhere up to a 600, right? So all of these standardized tests have these different numbers and all of that. So the question, whose achievement was higher on the mathematics portion of their national achievement test? Well, it's really hard to tell when you've got two different scales that we're talking about. But we can come up with z-score. So to compare these, we're going to calculate both of their z-scores. So go ahead and pause the video and calculate each girl's z-score and then tune back in to see if you did it right. So go ahead and check your work. If you calculated it right, you should have gotten that Amy got a z-score of around 1.9. I didn't tell you what to round to. You could have said 1.89. And Steph got a z-score of about 1.8. So these ladies scored very well on these tests because they are above the mean, but Amy scored slightly higher. So Amy did a little bit better based on her z-score. All right, you're finished with this lesson. Go ahead and start the homework.